This is gonna be my first YouTube video, but this is my second take. The reason being, my first take, everything got erased. I actually didn't press the record button, and then we went on and talked for 30 minutes. So hopefully this one is gonna be a little bit more precise. So what I want to share today is my interview question that I give to candidates over the phone call. So this is Microsoft phone interviews. A lot of phone calls we ask, tell me about yourself and a whole bunch of questions. But most of the biggest part for me is really I make the decision to give the recommendation for incline decline based on how they answer the technical questions. So the question I give candidates is given an array of integers and target numbers, find that target numbers, like where in the array, what index does it live. So here's the example. Obviously the target number is 7, so the index is 3. So this is what I'm looking for. The way that we analyze this is really by steps. The first step is really asking for clarifications. Is the array sorted? So a question you can ask. Talk about input. Is target is that unique? Is the target always going to be in it, or do we need to handle the edge case? And then definitely the big one is how big is the array? Because if the array is huge, then in that case, then we need to really handle different read, because we might not be able to read it all at once. So the second step we want to talk about is approaching iterate. Given that the array is already sorted, it's not, the number is unique, we don't need to handle the edge case. We always just return the first target number's index, and also the size is small enough to read, so we don't need to care about truncate your memories and read a part by one part. So we can really just go for the approach, and then really the first step is brute force, and then we can just read through everything. That's a brute force. And then we also have binary search. Since it's sorted, we can do all of log n. So the third step after you do the analysis is like, okay, now we want to really just go ahead and go with the approach of binary search. So we need to implement and test. That's the third step. And then for this third step, first draw out what you want to test. What are some of the test cases you want to cover? What are the corner cases you want to cover? I love to start my solution with a class form, so that way it's more robust. So you can actually go through your test cases, and you can add even the test functions. You can add all the class variables. It's very structured. That's something that interview will be looking for. So for my binary search, it's a really standard way of writing binary search. I compare the middle part. If the middle is smaller, if it's smaller, then you go to the left side. If it's bigger, you go to the right side. So this part is where we have a stop conditions, where we handle the edge case. If not, then we just kind of look at the middle to see which part we want to do this recursive code. But keep in mind, recursive code actually takes some spaces, because you can make a log n code before you can actually close down all the functions. So recursive code actually takes some spaces. That will be log n spaces. But if you do it in a for loop, you can do exactly the same thing in for loop. In that case, then obviously that's not going to take extra space. The next thing that we want to go through is the follow-up questions, right? If we look at the code here, you can probably spot that we use star plus end divided by 2. A lot of candidates make this mistake. So what I will ask is, what's wrong with this? Since we are giving you an integer array, meaning this array could potentially have a lot of numbers, even though it might fit in the memories, but the numbers can range, like the index of numbers could be almost very, very big, almost to the end. So when you have index of star plus end, if it's bigger than 2 to the 32, obviously integer is 4 byte 2 to the 32. If it's bigger than that, we'll get an overflow problem. So what do we do? In this case, if we want to solve the overflow problems, we should just have a displacement where we start, and then we just do the difference and divide by 2, and that should give us the number. And then the second follow-up I love to ask is, given if you have the special get value index thing, you can get the value of this particular index. And then this array is huge, really long. It's an infinite array. So you won't actually have the n index. So what would you do, right? So if we just go back to our drawing board, go with brute force solutions, we can also read through everything at once. And then we just read through every single one of them. Obviously, that's going to be O1 space with O1. Um, but then you can actually improve it. Like, what if I just jump, 3 space at once or 2 space at once? So I look at every second numbers. Then obviously I'm looking at n divided by 2. But when n go to infinity, well, that's still O of n. So obviously, it's getting smaller, but it's still really big because you're actually moving constant. So can we actually try to move not constant? So we can double every time we iterate through the array, we double it. So we look at the second number, we look at the fourth number, we look at the eighth number, we look at 16th number. This will actually give you, and then until we get to the end. So how many times when we actually do the lookup, we actually do log n lookup. So this number, the time complexity here is also O of log n with O1 complexity. So this is another way of doing, binary search that's not really having the n. You just double every time, you still get a binary search. So that's kind of where I want to stop here for this tutorial. So subscribe, like, thumbs down on the videos. I will make more of different interview questions. Hopefully this is helpful. Thank you guys.